told you you were living inside a black hole right now, would you believe me? And not just you. Everything in our observable universe would be inside that black hole. And while this sounds like a great science fiction movie, new data from JWST, the most powerful telescope in space, has shown it really could be true. And if it is, the repercussions are honestly insane. The Big Bang would essentially be a white hole in disguise. But what is a white hole, and more importantly, what did they see? The collapse of a star into a black hole and the Big Bang expansion are both solutions to Einstein's field equations. In these solutions, the curvature of spacetime and density approach infinity. Classical physics fails and we get some really strange results. It's this similarity that has caused some scientists to ask, could these two solutions be literally two sides of the same coin? Their first similarity is the singularity. In the beginning, everything in the universe was squished into a point with infinite density. This is the space-time singularity that the Big Bang originated from. Black holes, on the other hand, have an equivalent singularity of infinite density. Instead of it existing at the beginning of time, their singularity exists in the heart of the black hole.
I wonder if he actually knows what he's talking about, or if he's just like reading it, you know? Like, if he's like reading this off a screen, or does he actually know this?
Their
If he actually knows this, he has to be like the best scientist.
Similarity is the
With space.
horizon. A black hole's event horizon is a sphere around the singularity that represents the point of no return. Once something passes this horizon, it can never come out. Our observable universe has something similar known as the particle horizon. This sphere represents the farthest distance from which light could have arrived at the Earth since the Big Bang. Nothing from the outside of the particle horizon.
Yes, I heard, because once light happened from the Big Bang, there still could be space outside of what we can't see, because light hasn't reached it yet. That is so insane to think about, that our space could be like 30 times bigger, but we won't know until like 30 times 8 billion years. So they say.
Can ever get in, and nothing from the inside of the event horizon can ever get out. Two sides of the same coin. And this isn't just a hand-wavy similarity either. You can do the math and show that if you take the equation for the event horizon of a black hole and substitute in a value for the...
See, like, this stuff. This is just ridiculous. Like, who's like, yo, this is fun? Because there's like absolutely no way. Let me change my face cam. But there's like actually no way people look at this and I was like, yes, this is fire.
The mass contained in...
Like, if someone told me, you don't know the event horizon radius, I'd like...
Inside our observable universe, the resulting event horizon exactly matches the cosmic horizon we observe in our universe today. People started noticing these similarities over 50 years ago. Perhaps the Big Bang was essentially a white hole eruption inside another universe's black hole. White holes are essentially the opposite of black holes. Everything must exit the white hole and nothing can enter. This field is known as black hole cosmology, and it basically just says that everything we see in the universe, you, me, the galaxies, the sun, the earth, all of it is contained inside a massive black hole. That particle horizon that we can see is literally the event horizon of the parent black hole. To understand what JWST saw, you first need to understand the cosmological principle. This principle just states that once you zoom out far enough, the universe should look the same in every direction. It should be homogeneous, meaning if you took two random boxes of space from the universe, there should be about the same number of galaxies in each one. It should also be isotropic, meaning no matter where on the sky you look, you should see about the same thing. Galaxies, stars, nebulae.
That's weird.
You get it. There should be no big gaps or inconsistencies. This principle underlies all of cosmology, and every single experiment we've done in the past has agreed with it. All of them except for maybe this discovery from JWST.
Brother.
Just before I show you what JWST found, I need to thank the sponsor of this video, Odoo. Okay, now here's where things get interesting. A new paper was just released that looked at 263 spiral galaxies located billions of light years away. They wanted to see how many of them rotated in a clockwise direction like this, and how many rotated anti-clockwise. If the cosmological principle is true, we should expect to see half of them rotating in each direction. But JWST found 2/3 of the galaxies rotated clockwise, and only 1/3 rotated anti-clockwise. And as the author of the paper writes, because the black holes spin, a universe hosted inside a black hole is also expected to spin. This suggests that a possible explanation for why 2/3 of the galaxies appear to be rotating in that clockwise direction is that we're inside a black hole that is also rotating in that same clockwise direction. But wait, black holes can rotate? Well, yes, and most of them actually do. There are really two kinds of black holes. Non-rotating ones called Schwarzschild black holes, and rotating ones named Kerr black holes after the New Zealand physicist Roy Kerr, who first solved Einstein's field equations for the rotating case. Importantly, these Kerr black holes carry angular momentum with them, dragging the very fabric of space-time around with it. This means that any matter that enters the black hole will inherit this preferred axis of rotation. Later down the line, if they form into galaxies, they too should exhibit this inherited rotation. This is one of the proposed solutions for the JWST result. But this solution is only possible with rotating black holes for one very specific reason. You remember that singularity we spoke about earlier, right? That single point of infinite density inside the heart of every black hole. Well, if the black hole is spinning, that single point is no longer a point. Instead, it forms a ring. And it's this ring that unlocks the possibility for the Big Bang to be disguised as a white hole. White holes are essentially time-reversed black holes. Like I said, nothing can enter, but everything must exit. Since the singularity inside a rotating black hole becomes a ring, that leaves a tiny space that you could, in theory, fall through. Importantly, this white hole rebound would look like space itself expanding if viewed from the inside of the black hole. This is getting eerily similar to our description of the Big Bang. If this is true, and the Big Bang really is just a white hole in disguise, how could we tell? Like, what would the difference be between a universe that originated from a white hole and one that came from the Big Bang as we know it today? The answer is really just...
Yeah, I'm not gonna lie. I'm confused. But low-key, I think he's onto something. It sounds right.
more inconsistencies like these galaxy rotations that JWST has supposedly spotted. Inflation in our Big Bang model should really iron out these inconsistencies, making the cosmological principle hold true, while the white hole universe would leave some hints behind. This could look like rotations or even matter clumping together in a weird way. What's definitely true is we need more data to continue unraveling this mystery. Imagine this is all true and we really are living in some black hole in some other galaxy somewhere. What does this tell us about reality? Well, first, that black hole would be insanely big, orders of magnitudes bigger than anything we've ever seen. The black hole that contains our universe would be as massive as 40 sextillion suns. That's 4 followed by 22 zeros. Its event horizon would be 14 billion light years wide. For context, if Sagittarius A star, the black hole at the center of our galaxy, were just the size of a single virus, the black hole that contains our observable universe would be the size of the Earth. This would also suggest an infinite series of universes all linked by black holes. In each baby universe, you would find new black holes that contain baby universes of their own. This could lead to a scenario where universe families that create the most black holes are the ones that get to live for the longest. Literally survival of the fittest, but instead of it being animals, it's universes. But we can't get too far ahead of ourselves. The entire scientific community isn't convinced we are living inside a black hole, at least not yet. As with everything in science, a paper gets published and then it gets peer reviewed, and then the community starts to discuss the results, trying to come up with the best possible explanations. People have tried to make these same galaxy rotation observations in the past, and every time a positive result for asymmetry was found, it was later attributed to subtle biases in how the observation was actually taken. For example, the motion of the Earth could throw off the result. And an even more obvious point of skepticism is that the study only looked at around 300 galaxies, when there's trillions of them in our universe. The actual region of the sky that JWST looked at to see all of these galaxies can be contained within the area of a pinhead held at arm's length. So we need to look at the rest of the sky as a whole to get a big picture view of galaxy rotation in the universe. It's definitely true that we need more data, but this result is interesting, and this idea of us living inside a black hole might sound just like science fiction, but it's a real
But if it's isocentric, whatever, where it's like even on each side, it shouldn't matter how much you do, right? It should just be even regardless. No?
possibility backed by solid physics, so it shouldn't be overlooked.
I'm not gonna lie, I think he's onto something there. That was a good brain teaser, for sure.